What is the count now? I think 36. Okay, we'll start. We'll not wait more for them. In the last lecture, we have, yes? Is that it? Yes, please.
भाई ये तो 50-60
roll number 61. Roll number 61. Any issue? Okay. Okay. In the last lecture, we saw that oxidation ditch and oxidation pond. So we were studying about the low-cost wastewater treatment systems. Is it? Now in the low-cost wastewater treatment system, first system we have discussed about the oxidation ditch. Oxidation ditch, simply there is a requirement of screening. Then wastewater will go to the oval-shaped tank. Intentionally, it has to be designed oval-shaped to reduce the cost required for the movement of the wastewater in that. Okay, so here you can apply the aerator, and that aerator will rotate in one direction. Okay, if it is rotating in this direction, the entire sewage will be rotating in the same direction. Okay, and this is not only providing the oxygen, but also it is making that sewage to remain in a suspension form. Okay, so two-way it is helping us. Then the sewage will be treated, sewage will be output. There are two types of oxidation ditch pond can be designed. One is the intermittent type of oxidation ditch. Okay, DITCH, oxidation ditch. In the intermittent type of, it is also called as fill and draw type, or we can say it is a batch type. A batch of sewage is allowed to enter, and then it will be aerated for a particular period by keeping aerator on. By keeping that aerator on. Then once the aeration period is over, stop that aerator, allow to settle down the sewage in the same tank. So the sludge will be settled at the bottom, and supernatant can be removed from the top surface and sludge can be removed from the bottom surface. Okay. Then after removal of effluent, treated effluent and settled sludge, once again you can restart, you can allow to enter the new batch of wastewater through the inlet wall A and close the outlet wall B. Again, the same cycle will continue. That is the first aeration and then sedimentation and settle the sludge. Okay, this cycle again it will repeat for the another batch. That is nothing but the intermittent type of oxidation ditch. Now another type of oxidation ditch we have discussed, that is continuous type of oxidation ditch. What happens in a continuous type of oxidation ditch? In a continuous type of oxidation ditch, there is no need to provide the no need to close wall A and B. It will be remain open continuously, and the sewage will move in this direction continuously. The aeration will be performed in this tank. Okay, and for sedimentation purpose, we will provide a separate secondary clarifier. A simple type of design we can construct, and we can allow to settle the sludge in a secondary clarifier. And then here supernatant or the effluent, we usually call it as a effluent, will be removed from the top surface and settled sludge will be removed from the bottom. Okay, settle the sludge. So this will be the activity being performed in a continuous type of oxidation ditch. Okay, this we have discussed in the last lecture. Before that, we have studied about the oxidation bond. These diagrams and all those explanation you have written already. So I will take just revision of 5-10 minutes and then we'll solve the design problem on the oxidation bond. Okay, oxidation bond, I have shown to you figure you have drawn already. It can be designed usually rectangular shape in shape. Okay. A wall can be constructed which should have a slope at both the side, towards the inside as well as towards the outside, to get the proper strength to this wall. Okay. Then the sewage will be allowed to enter at the center of this tank. Okay, this type of diagram you have drawn already in the last lecture. Is it? So that's why I'm not drawing it fair. It will be a rough diagram because you have already drawn. Okay, it can be divided into two parts. This will be the inlet provision. Okay, sewage will be entered. It will. Okay, and the sewage outlet will be collected at the another end. So this kind of design we should go for to avoid the short circuiting of inlet and outlet. If inlet and outlet is constructed at the same side, there will be a short circuiting. What is meant by short circuit? What is meant by short circuit? It will not allow to flow the mix that entire process. Suppose here I have provided the outlet, and this is the inlet. So the sewage will come from here and it will go out from this. So this portion will remain as a dead portion. It should not be there. That is known as the short circuiting. Okay. So to avoid that, a design has to be provided this way. And you are allowing to enter the sewage at the center with the help of pipe. So it is just an open tank. You are continuously depositing the sewage, and 3 different actions can be performed: aerobic action, anaerobic action, and facultative action. Okay, either of these actions will be selected as per the depth of oxidation bond provided, and it will perform the decomposition of organic waste in the designed tank. Okay, so this is nothing but the oxidation bond that we have discussed. We have discussed advantages and disadvantages. Okay, guys, we will solve problem on the same now. Take down the problem. Design an oxidation bond Design an oxidation bond for the following data. Design an oxidation bond for the following data. Okay, data, I will write it on the board. बोर्ड से दिसतोय का तिरका झाला माझ्या फोनची बॅटरी संपत आली त्याच्या अगोदर आपल्याला डिझाईन प्रॉब्लेम संपवायचे बाकीचं लेक्चर लॅपटॉपवर घेता येईल इट इज इम्प्लाइड का असं दिसायला लागलंय मला पण कळलं दिसतोय आता नाही बघा दिसतोय का आता दिसतोय का बघा I think right now. Okay. So the first design an oxidation bond for the following data. First data is the location. Location. It is given to you 20-degree latitude. Sorry, 24-degree latitude. Second data is given to you. Elevation 900 meter above mean sea level. Elevation is given to you 900 meter above mean sea level. Third data is given to you mean monthly temperature. Mean monthly temperature. It is given to you 30 degrees Celsius maximum and 10 degrees Celsius minimum. Fourth data is given to you. Population to be served. Population to be served. And it is 8,000. Fifth data is given to you. Sewage flow. Sewage flow. It is 160 liter per capita per day. 160 liter per capita per day. Then influent BOD, sixth data is given to you. Influent BOD. BOD 5 is equal to 300 milligram per liter. Then seventh data, desired BOD 5 is given to you 30 milligram per liter. 30 milligram per liter. Eighth data is given to you. Pond removal constant at 20 degrees Celsius. Pond removal constant at 20 degrees Celsius is equal to 0.1 per day. And the ninth data is sky clearance factor. Sky clearance factor is given to you 0.9. Okay. So many of the times sky clearance factor is not given, but for your examination, it will be provided sky clearance factor. Okay. So this is the data provided, or this is the example given to you. Now you need to solve it further. Okay. Just read once. Timing, I will add some ink in my pen. Black acid. माहिती का कुठून निघतं? ते कुठून निघतं माहिती का? Hope so. Okay. I think you might have read that problem. Okay. Now it is asked you to design the oxidation bond. Okay. So first of all, what we need to calculate? First of all, you need to calculate the total BOD per capita. Population is given to you. Rate of sewage flow is given to you, and influent BOD is given to you. Is it? So you can calculate the total BOD. Total BOD per capita. Okay, it will be, you can calculate it was disconnected. Disconnectation. So first of all, you need to calculate the total BOD per capita. Okay. So for that purpose, a population data is given to you. The population of that particular village is 8,000. Then what else data you have? Influent BOD. It is 300 milligram per liter. And next is given to you sewage flow. It is 160 liter. So it is milligram per liter. Is it? BOD is given to you milligram per liter into 160. It is liter per capita per day. So capita will get lost now because we have multiplied by the population. So the capita will go for. Then liter gets cancelled. Then tell me the answer in a kg per day. Tell me the answer in a kg per day. 8,000 is the population, 300 is the sewage flow, and 160 liter per capita per day is the sewage flow, and 300 is the BOD in a influent sewage in milligram per liter. So unit conversion you need to go for and give me the final answer for the total BOD per capita BOD per day. You should talk. I will not watch the your chat box. Yes, please. Answer, please. Is there anybody we have completed? Simple calculation, why you are taking that much time? Yes, please. Our first session time is about to get over. So before that, you need to tell me answer. What is the issue? Why you people are not answering me? Is that it that much difficult to convert milligram to kg? Yes. Is that it difficult? Yes. 384 kg per day. Correct. 384 kg per day is the answer for total BOD per capita. Is it? Now for that BOD, we can go to design the oxidation pond. Okay. So the next step, we should go for permissible aerial BOD loading. This is the first step. Second step, you should go for permissible aerial BOD. Aerial BOD in the sense, as per the climatic conditions and elevation. So you need to apply two factors, two correction factor. First correction factor is the elevation factor. And second correction factor is the second correction factor, you can go for sky clearance correction factor. But sky clearance correction factor is already given to you. It is 0.9. But elevation correction factor is not given to you. Is it given? It is not given. Is it? So you need to find out the correction factor for this elevation. So what is the elevation given to you? 900 meter above mean sea level. Now who will tell me the formula to find out the correction factor for the elevation? Someone please answer. Go back and see in your notebook you have written. Yes. Elevation factor, how to calculate? 1 plus 0.003 into EL. Okay. So 1 plus 0.003 EL is given to you 900 upon 100. Okay. So find out the elevation factor and tell me the answer. Calculate and tell me the answer. It is for which degree latitude? 224 degree latitude. It is for the elevation at 24 degree latitude. 24 degree latitude elevation is okay. Someone has written answer. Let me check. 1.07. It is 1.027. Okay. So this is the correction factor for the elevation. Now go and check your BOD. It is given in the last lecture. BOD loading chart at 24 degree latitude. How much is the BOD loading chart? Priyanka, it is wrong answer. 9.027 is the wrong answer. It is the correct answer, 1.027. It is written 1 plus 0.003 into 900 upon 100. So the correct answer is 1.027. And the sky clearance factor is right here. Sky clearance factor already given to you. It is 0.9. Now I request you all to go back and check what is the BOD loading. What is the BOD loading for 24-degree latitude? Check in the chart. It is, I think, 225 kg per hectare per day. Am I right? Someone has written in the chat box. Yes, 225. What is the unit? It is 225 kg per hectare per day at the 24-degree latitude. Okay. So if you have finished up with this, I will erase the board and then I will solve the further part. Shall I erase? This side also I will erase. Wherever data required, you will answer me. Is it? I hope. Okay, now BOD loading at 24-degree latitude is equal to 225 kg per hectare per day. Okay. Now, we'll apply the correction factor. Apply the correction factors. Correction factors. So, then total aerial load. Correction factor for aerial loading is equal to 325 into what is the sky clearance? It is 0.9. And what we have calculated for the elevation, it is 1.027. So, sky clearance, how to apply the correction factors? The sky clearance should be, sky clearance should be multiplied and the elevation clearance should be at the denominator. Okay? Multiplied by 0.9. So you will get an answer that applied correction factor for BOD. BOD loading after correction, or you can say corrected BOD loading. Let me know the answer. Obviously, so this factor 225 is given to you in a kg per hectare per day. So your answer will be in a, yes, someone has written in the message box. Let me know what is this. Ma'am, video off ahe. Oops. That is सांगायचं. नाहीये, on आहे video. Pin to me. There are two Vidya and Kshirsagar Zoom are there. So you might have been at the wrong place. Pin to me, you will get answer. You will be able to see the board. So the BOD loading is the 225. We have applied the correction factors. Now corrected BOD loading. Corrected BOD loading will be Tell the answer in a, obviously it will be in a kg per hectare